Hello world, and this is a very special edition of Versus Codewars. In today's episode, we are going to be running it back again. We are going to be revisiting some of my favorite katas, which I have done on previous episodes of Versus Codewars, but with a catch. Instead of JavaScript, we are going to be tackling these katas in Python. This is going to be a big learning experience for me, as I have never really much used Python before. And I'm sure it will be a pretty good learning experience for you too. So without further ado, let's get to it. Enjoy! And I hope everyone is having a wonderful and safe day today. We are going to be doing something quite a bit different today. Today, we are going to be revisiting some of my favorite katas, which I've done over the past episodes of Versus Codewars, in a different programming language. In this case, we are going to be doing today's katas with the Python programming language. And we begin today with the very first kata that we ever did on Versus Codewars, the descending order kata. The goal of this kata is to write a function that can take any non-negative number as an argument and return it with its digits in descending order. Essentially, we have to rearrange the digits in the integer, actually, to create the highest possible integer, like the ones you see in the examples here. Alright, let's go ahead and get started with this one here. In Python, we define our functions with the def keyword, followed by the function name here. And then in these parentheses here, we have our arguments here. In this case, our number. Now, instead of curly braces for our function body, we follow our function declaration here with this colon right here. And then we begin the function body here with indents going downwards here. Now, in Python, the function ends when we no longer have this indentation beginning with our new lines here. Alright, what we're going to go ahead and do here. But first, let's go ahead and see what happens when we convert this number into a string. Now, in JavaScript, we use console.log to log our outputs to the console here. In Python, we use a function called print. And it takes multiple arguments here that correspond to what we want to print. In this case, we just want to print our number here. And in JavaScript, it's not in Python, it's not necessary to use semicolons here. Let's go ahead and punch this into our terminal to see what this looks like here. We're going to do Python 3, and we're going to pass in our Python file here, descending order. And we actually need to call our function here. 3, 4, 5, 6, 7, 8, 9. Alright, let's try that again here. And the print function, as you can see, spits out our number here that we passed in. Now, what we need to do, we need to convert this number into a string here. And what we'll go ahead and do, we're going to go ahead and set a variable here. Number string. And we're going to set that equal to... Python has another function called str, which is used to convert numbers into strings. We're going to call that function here. We're going to pass in our number here. And next, what we need to do, we need to split this string into its individual characters and somehow convert those into numbers, numeric digits. So what I think we'll go ahead and do, first we'll go ahead and do number chars, set that equal to split, and then we'll go ahead and split that number string here. Split is not defined. Now, how do we split into individual characters here? Number string dot split. Yeah, okay. Anyway, we'll use a blank string separator here. I think we can just go ahead and pass nothing into this and it'll have that same result here. Let's go ahead and print that here. Yeah, running that through Python again. Okay, we might actually need that blank string then. Let's try that again. Apparently that does not work. Empty separator. Maybe if we try passing in none. No? No, what I want to do is I want to split this string into its individual characters here. Let's see what the IntelliSense has to say about this. It's a splintering means split according to any white space. Now, what if we wanted to split with any, like a blank string though? Alright, I will be right back. One moment. Can you tell I have very little familiarity with Python whatsoever? Now, apparently, what we have to do in order to split a string into its individual characters with a blank string separator is we have to use the constructor function of a class called list. In Python, arrays are known as lists. So, what we'll go ahead and do, we'll take our number chars, we'll set that equal to the return of the list constructor here, passing in our number string to split that string into its individual characters here. Running that through Python, as you can see, we now get each of the characters of our string here. What we need to do next is we need to figure out how to convert each of these characters into numeric digits. And what I think we'll do is how are for loops done in Python here? I think it's for index in range, or maybe for char in numbered chars. Now in Python, what we do with for loops, if statements, while loops whatsoever, we also have to follow this statement here with a colon to tell Python that we are beginning a new block of code here. And this new block of code will have further indentation apart from our function body right here. Anyway, what we'll go ahead and do, first let's go ahead and print that char just to see if that's working alright here. And yep, we are getting each of these individually here. Alright, let's go ahead and do digits. I think we'll try setting that to an empty list here. And then digits dot append, and then we'll use the int constructor to convert this character into a numeric digit right here. And then at the end of this for loop here, let's go ahead and do a print digits here. And we have an array of each of our digits here. We're getting close now. What we need to do now is we need to sort this list of integers in descending order. And I think what we'll go ahead and do, let's do digits.sort. Yep, sort does, the list object does seem to have a sort method here. Let's go ahead and, in order to sort it in descending order, apparently this method here has a flag called reverse, which can accomplish just that. And we'll go ahead and set that to true here. In Python, the Boolean identifiers have to be capitalized here. Now let's go ahead and print that array again. It looks like the sort method performs the sorting in place here, so I think it does modify that original array here. Yep, it does, and let's see what happens when we go ahead and join this list back together here. Does list have a join method? No. Let's have a look at some of these methods here. I don't think so. Let me get rid of this terminal here. Let's go ahead and let's go ahead and create a string here. Descending string, set that equal to a blank string. Then for digit and digits, descending string equals descending string plus str digit. Oh, wait a minute. Yeah, I think that's the way to go here. Let's go ahead and print that descending string here. And let's run that through the interpreter again, and we get a string form of our number in descending order here. I think we have to return this as a number. Yup. So what we'll go ahead and do return int descending string here. Let's go ahead and print that down here. And we get the numeric form of our integer in descending order. Alright, let's go ahead and punch this into Codewars to see what this looks like here. Oops. Let's hit test. And we are good. We just did our very first Python kata. Can you tell this is the first Python kata I've ever done? Anyway, there is a better way to execute this kata solution here. Apparently, Python also has a function called sorted, which can take any iterable object, including a list or a string. What I could have done was, I could have taken the number, converted it into a string, run that through the sorted method with the reverse flag set to true, and then I would have taken that resulting sorted array and then converted that into join that together into a string by taking a blank string and calling the join method on that, passing that array in. And then I could have taken that string and converted that into the integer with the integer constructor here, and that would have been the return value of that kata solution. I think the next kata we are going to do is don't give me 5. In this kata, we get the start number and the end number of a region, and the goal of the kata is to return the count of all numbers therein, except for numbers with a 5 in it. The start and the end number are both inclusive here. Look at these examples in the kata instructions here. Here we have the range from 1 through 9. We have 1, 2, 3, 4, and then we skip the 5 here, and then 6, 7, 8, and 9. And consider the range 4 to 17. We have 4, we skip the 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Then we skip 15 because that contains a 5, and then we go to 16 and 17. The result may contain 5s. The start number will always be smaller than the end number, and both numbers can also be negative. Alright, let's go ahead and get started with this one here. We have def don't give me 5. Our Python kata functions will be in underscore kebab case here. Alright, anyway, what we'll do here, we'll have 2 arguments here, our start and our end. Now, what we'll go ahead and do, I think Python has a range function for for doing range-based for loops here. Let's go ahead and give that a try. For, I think it's index in range start to end. Let's go ahead and print that index here. And we're going to go ahead and do print, don't give me 5. We're going to pass in, let's do -10, or rather -20 to +20 here. Now, what we'll go ahead and do, we're going to do Python 3, don't give me 5. And we get the range from -20 to 19. We actually don't want that here because the upper end has to be inclusive as well. So we'll go ahead and do n plus 1 here. Now we get the proper range from -20 to +20 here. Now, what I think we'll go ahead and do is, I think this kata expects us to return a list here, right? No, just the number of elements therein. Alright, what we'll go ahead and do then, let's go ahead and keep track of a count here. We'll set that equal to 0. And then at the end of this function here, we'll return our count right here. Now, what we'll go ahead and do is, inside of this for loop here, we're going to do an if statement here. We're going to do if the character 5 is not in the string conversion of our index here, we'll go ahead and do count equals count plus 1 here. Alright, let's go ahead and run this through our Python interpreter here to see what this looks like, and we get the return value of 37 here. Because we have 40 elements here, 15 would be omitted, that's 39, 38, 37. There should be 30, this should be 36 if I'm not mistaken here. Let's go ahead and print that index here. Alright, I'm going to go ahead and save that. Let's go ahead and clear this terminal here. We're going to run that through the Python interpreter again. Yeah. I think it's right. Let's go ahead and try our 1 through 9 in the kata, from the kata instructions here. And we get the result of 8, which is what we want to see. Let's try the other example here from 4 to 17. And we get the return value of 12, which is also what we want to see. Alright, I think we're ready to punch this into Codewars now to see what this looks like. Let's go ahead and take this. And copy that, paste that here. Let's run the tests. And we are good. In JavaScript, if we wanted to find out if a string or an array contained a certain character or element, there were some methods available that we could use to do that, including the includes method, the find method, and the find index method. And in the case of strings, index of and last index of. In Python, there is a built-in operator, or rather two built-in operators called in and not in, which would check to see if a certain character or element was present or not present, respectively, in any given iterable object, be it a string, a list, or a tuple. In the case of this particular kata solution, you saw the in operator in action in our if statement right here. Here we check to see if the character 5 was present in the string conversion of the indices in each iteration of our for loop. The in operator will return true if that character is present inside that string. Similarly, the not in operator will return false if such a character is present in that string instead. The next kata we are going to revisit is Array.diff. The goal of this kata is to write a difference function which subtracts one list from another and returns the result. It should remove all values from list A which are present in list B whilst keeping their order. If a value is present in B, all of its occurrences must be removed from the other array. Alright, let's go ahead and get started with this one. Let's do def Array.diff, and we'll have our first and second lists here. Now, what we are going to do is I think what we will go ahead and do, we're going to do a result list right here. And then for element in first, we'll have our for loop right here. And I think what we do is result.append, or rather, first we need to check to see if our element is not in second. And if that's the case, we'll go ahead and do result.append element here. And we can go ahead and return our result right here. As I mentioned in the reflection before, the not in operator will return true if this element is not present in the second array right here. Alright, let's go ahead and test this out here. We're going to grab this array right here from the kata instructions here. And we are going to do a print statement down here. And we're going to paste that right in here. Let's feed that into our interpreter here. And we get the resulting array, or rather list, 1 and 3. Now, what would happen if we did this list right here instead? We should get a list with the lone element 2 right here. Let's have a look at some of these other tests here. What about an empty array, or rather empty list, and the list 1 and 2? And we would get an empty array, and we do want to see that. I think we're ready to punch this into Codewars now to see what this looks like here. And we are good. Here is the better code solution of the day. Pay mind to the code snippet you see below me here. What you see here in Python is known as a list comprehension, and it's basically a way of implementing our code solution with just one line. In this particular case, the list comprehension goes like this: X for X in A if X not in B, which basically reads this: place element X in the array for each element in array A if that element is not present in array B. I still have a lot more to learn about how list comprehensions works, but I think, if I'm not mistaken, that first part of the list comprehension can be any modification on that statement. So if I had a list comprehension that said, for example, X times 2 for X in range 1 to 4, I think I would get a list that said 1, 4, 6, 8. Let me know if I have that right here. Again, I still have a lot to learn about this. If we list all the natural numbers below 10 that are multiples of 3 or 5, we get 3, 5, 6, and 9, and the sum of these multiples is 23. The goal of this kata is to return the sum of all of the multiples of 3 or 5 below the number passed in. Additionally, if the number is negative, return 0. If a number is a multiple of both 3 and 5, only count it once. Let's go ahead and get started with this one here. Alright, we will def solution. We'll have our number here. And what we will go ahead and do, we'll go ahead and keep track of a result here. Or rather, result equals 0, and we are going to return that result. Now, what we are going to go ahead and do here, we are going to do I wonder if list has some here, like a reduce function. Something like reduce. Maybe not. Alright, let's go ahead and do a for loop here. For I in range 0 to number. And keep in mind, range returns the range of numbers with the upper end being exclusive here. And that's going to be useful for this kata here. Anyway, what we'll do is, Python also has the modulo operator here. And the modulo operator returns the remainder of the left-hand operand divided by the right-hand operand. So what we'll do is, if I modulo 3 is equal to 0, which would indicate that this number here is a multiple of 3, or I think we use the or keyword here, I modulo 5 is equal to 0, which would indicate that I is a multiple of 5. We'll go ahead and do result equals result plus I here. And I think that is all there is to it here. Let's go ahead and test this out here. Print solution. We'll pass in 10 here. Alright, we'll do Python multiples. And we get the sum of 23, which is what we want to see. Let's do a larger number here. Let's try 200. And we get the solution 9168, which is what we want to see. Let's try a larger number here, 20,000. How about 2 million? Looks like it's handling it just fine. Alright, let's go ahead and punch this into Codewars to see what this looks like here. And we are good. As it turns out, there is a way in Python to sum up the numeric elements of an array, and it's the function known as sum. Sum takes an array of numbers and, as the name of the function alludes, returns the sum of those elements. It would be the Python equivalent to using the array object's reduce method in JavaScript, with the predicate function that would return the accumulator plus the value. The next kata we are going to be revisiting is the digital root kata. The digital root is the recursive sum of all of the digits in a number. Given a number, the goal of this kata is to take the sum of the digits of that number. If that sum has more than one digit to it, we continue reducing that sum in this way until we have a sum that is only one digit. The input will be a non-negative integer. Let's go ahead and get started here. We will def digital root, and we will have our number right here. Now, what we are going to go ahead and do is, I think what we'll go ahead and do is we'll have our sum here. We'll have a result here. Set that equal to -1 here. I think that's good. Go ahead and return that result right here. Now, we are going to continue a while loop as long as result is equal to -1, or result is greater than or equal to 10. Now, what we will go ahead and do, get rid of that triple equal sign, this ain't JavaScript here. What we will go ahead and do, actually, we'll go ahead and, we'll actually go ahead and take that result, set it equal to our number here. And then while result is greater than or equal to 10, what we will go ahead and do, we'll go ahead and take the digits. We'll set that equal to int char for char and str result. So what this basically says is, for each character in the string conversion of our result number here, we will take that character and convert that into an integer to get the numeric digit here. And then what we will go ahead and do, what we'll go ahead and do, we'll set result to that resulting array, and we'll pass that array into the sum function here. I think that will do. Let's go ahead and test this out here. Print digital root, and we'll pass in 16 here. Alright, let's feed that into the repo here. And we get the digital root of 7 here. Let's try 942. And this should give us 6 here, and it does. Let's try 132,189. And we get to the numeric root 6. And how about the number 493,193? And we get to the digital root 2. And that is what we want to see. I think we are ready to punch this into Codewars to see what this looks like. Run the tests. And we are good. The next kata we are going to be revisiting is the zipWith kata. The goal of this kata is to write a function that takes two arrays and a function, a lambda function, and zips the arrays together, applying that function to every pair of values, parallel in both arrays. The function value is one new array. If the arrays are of unequal length, the output will only be as long as the shorter one. Values of the longer array are simply not used. The input arrays shall not be modified. Let's go ahead and get started with this one here. We'll have our def zipWith. We'll have our function as the first argument, the first array as the second, and the second array as the third argument here. Now, first we need to determine which of these two arrays has the fewer amount of elements here. I think Python has min and max functions here, so I think we'll do zip length. We'll set that equal to min. Yep, min first dot length, or rather, the len function passing in the first and the len function passing in the second. Whereas we use the array object's length property in JavaScript, Python has a function called len, which takes any iterable, like a string, or in this case, an array, and returns the length of that iterable. And in Python, we also use the min function to calculate the minimum value of the arguments passed in this case, the length of our first and second arrays. Alright, what we will go ahead and do is, I think we do for index in range 0 to zip length. Alright, we will need to apply our function to the element of the first and second arrays at this given index here. And we will need a result array here, or rather a result list. And what we will do is we will run results.append, and we will append to this result array the return value of our function, passing in first at index index and second at index index here. And then after all that, we will return our result right here. Alright, let's go ahead and try this out here. Print zipWith. How about lambda AB A plus B. And we will pass that in for the function here. In Python, there is the lambda keyword, which indicates that we are writing a lambda function here. We start with this lambda keyword, and then we have the arguments for that lambda function, followed by the colon here, and then the body of that lambda function right here, which in this case returns the sum of A and B here. Alright, now what we will go ahead and do, we're going to go ahead and pass in our two arrays here. Let's go ahead and grab these two right here from the kata instructions here. Alright, let's go ahead and run that through the repo to see what that looks like here. And we get the list of numbers 0, 2, 4, and 6. Alright, let's go ahead and I think we're ready to run this through Codewars to see what this looks like here. And we are good. For our next kata, we are going to revisit a kata I actually was not able to include in the previous episode of Versus Codewars due to those aforementioned technical issues, and that is the bingo card kata. After yet another dispute on their game, the Bingo Association decides to change course and automate the game. The goal of this kata is to help the association by writing a method to create a random bingo card. A bingo card contains 24 unique and random numbers according to the following scheme. 5 numbers in the B column from the range 1 to 15. 5 numbers from the I column in the range from 16 to 30. 4 numbers from the N column in the range 31 to 45. There are only 4 numbers here because of the free space in the middle. 5 numbers from the G column in the range 46 to 60, and 5 numbers from the O column in the range 61 to 75. Let's go ahead and get started with this one. We have to return a list that looks something like this, if you have a look in the kata instructions here. Alright, let's go ahead and get started with this one here. Let's do def get bingo card. And for this one, we are actually going to need the help of a Python module for generating random numbers. And that module is random. And you can pull modules in Python using the import keyword. Alright, what we will go ahead and do is... First, I think we'll go ahead and set up the columns array here. And I think we'll just use a string that says bingo. And remember, any iterable in Python can be iterated over like a string right here. Alright, what I think we'll go ahead and do. I'm gonna have a look at some here. Print columns at 1. And what we'll do print get bingo card here. And we'll run that through the Python repo here. Yeah, okay. All right, well, we'll go ahead and do... Let's do a for loop right here for column index in range 0 to 5. And then we'll do print columns and column index here. And that gives us the letters B, I, N, G, and O. Alright, what we will go ahead and do here... We'll print up our lower bound. And we'll set that equal to... And it has to start at 1 here. So 1 plus 15 times column index. And then we'll do an upper bound here. We'll set that equal to lower bound plus 15. Let's go ahead and just print those here. Just to see what they look like here. And we have 1 to 16, 16 to 31. I don't think... maybe we just do lower bound plus 14 then. Yeah, 1 to 15, 16 to 30, 31 to 45, 46 to 60, and 61 to 75. And then what we'll go ahead and do, numbers to generate number count, or rather row count. We'll set that equal to... I wonder if Python has support for ternary operators, ternary conditional operations. Let's see. 0, 1, 2. If column index is equal to 2, 4, 5. Or maybe for if column index is equal to 2, else 5. I wonder if that works. We'll do print row count. And run that through the REPL again. So we have 5, 5, 4, 5, and 5. And we want to see that. Alright, let's go ahead and we'll do a second for loop in here for... I think we'll call it number in, or rather row index in range 0 to row count here. And then what we will go ahead and do, we need to keep track of a result array up here. We are going to go ahead and declare a variable called entry here, and that's going to be a string. We're going to do columns at column index dot join, and we're going to pass in. First, we actually need to generate our random number here. Do generated number, and we are going to set that equal to random dot rand int. We're going to pass in our lower bound and upper bound. And then we'll do generated entry. We'll do columns at column index dot join. And we'll convert that generated number into a string. Now, if our generated entry is not in our result array, we will go ahead and do result.append generated entry. And that should be all there is to that here. Now, after all of that, I think we can go ahead and return our result list here. Alright, let's go ahead and test this out here. Yeah, I don't think I was expecting that to happen here. Alright, let's go ahead and get rid of that for right now. And I think... does it... Or maybe if we try this. A little concatenation right here. Yep, I think that is working a lot better now. We have 5 B entries, 5 I entries, 4 N entries, 5 G entries, and wait a minute. We only have 4 G entries here. Alright, let's go ahead and print that row count here. And then run that again. Oh, wait a minute. Oh, yeah, okay. Alright, what we'll go ahead and do, I think we'll do a while loop here and here instead. While numbers entered is less than a row count. And then what we'll go ahead and do in here, numbers entered plus equals 1 here. And that should give us the proper number of entries in our bingo card now. And yeah, we have 5 B entries, 5 I entries, 4 N entries, 5 G entries, and 5 O entries. Alright, I think we are ready now to punch this into Codewars to see what this looks like here. And that test pass, let's hit attempt, and we are good. The next kata we are going to be revisiting is +1 array. Given an array of integers of any length, the goal of this kata is to return an array that has 1 added to the value represented by the array. The array cannot be empty, and only non-negative single-digit integers are allowed. We have to return, in our case of Python, none for the case of invalid inputs. For example, the array 239, when their digits are joined together, equals 239. adding 1 to that joined number would result in the array 240. And then adding, and then 4325 would return 4326 instead. Let's go ahead and give this one a try here. And we'll do def up array, and we'll have our list right here. And what we will go ahead and do, I think we'll go ahead and have, first we actually need to go ahead and validate each of the numbers in our array here. So what we'll go ahead and do, we'll do 4-digit in array, and then if the digit is less than 0 or the digit is greater than 9, then this array is invalid, so we will have to return, in our case, none. Now that we know that our array is valid, what we will go ahead and do is, let's go ahead and get the combined number, and we will run through the integer constructor the return of the blank string.join, and we will join together our array here. Let's go ahead and print that to see what that looks like. I'm going to go ahead and do a print down here. Up array 2, 3, and 9. Alright, let's run that through the REPL here. And sequence item 0, expected string instance int found. Oh, okay. So what we do in that case, str digit for digit in arr. Alright, now we have our combined number right here. Alright. And we should be able to go ahead and let's go ahead and change that to result number. And then we'll add 1 to that. Now, what we should be able to do is we will return digit for char in str, or rather int char for char in split str result number. Let's see what that looks like here. Split is not defined. Or rather, oh, right, list. That should work. Let's see what that looks like. And we have the array 2, 4, and 0, which is what we want to see. All right, let's explain what's going on here. All right, we have this for loop up here that we use to check to see if the elements of the given array are single-digit integers here. If any of these digits is less than 0 or greater than 9, then we know that this array is not valid, in which case we return none right here. Otherwise, when we go down here, we have a result number right here, and we set it to the following. We use a blank string and we run that through the join method. And we pass into it an array that is comprehended as follows. We take, for each digit in our array, we return the string form of that digit. And then we take the resulting number from all of this and we add 1 to it. Finally, we return another list using another list comprehension here for each character in the string form of this result number right here, split into its individual characters using the list constructor right here. We convert that character into an integer when we place that into the array. Now, running that with, for example, the array 239, we get to the array 240 in return right here. Let's try another array right here. 4, 3, 2, and 5. And we get 4, 3, 2, and 6. Now, if I recall right, I think we had to deal with instances of leading zeros in our tests when we were doing this in JavaScript here. Let's see what happens here. Alright, let's go ahead and print the array right here. Let's actually do that in the Kata solution here. Let's print that out here. It seems we have an empty array right here that we're dealing with. So, what we'll go ahead and do, if we call the len function passing in our array, and the return value of that is 0, we will return none here. Let's go ahead and paste this into our Kata solution. And we are good. The next kata we will be revisiting is valid parentheses. The goal of this kata is to take a string of parentheses and to determine if the order of those parentheses is valid. The function should return true if so and false otherwise. Have a look at these examples right here. In this first one, this opening parenthesis is paired with a closing parenthesis. So this is a valid sequence of parentheses, so we return true. This one, however, we begin with a closing parenthesis right here. So this is not a valid sequence of parentheses here, so we return false. Here we have a lone parenthesis right here. And this means this is not a valid sequence of parentheses here, so we return false. And in this fourth one here, we have an open, open, close, close, open, 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 close, open, close, close, open, close, close. So each of these parentheses here is properly associated with the closing parenthesis. So this is a valid sequence of parentheses here, so we return true. Let's go ahead and get started with this one here. Alright, and what we will go ahead and do, we'll def valid parentheses, and we will have our string right here. Now, what we are going to do here is we're going to want to keep a score here. So we're going to do a score here, and we're going to set it equal to 0. And we need to return whether the score is equal to 0 at the end here. Now, what we are going to go ahead and do, we are going to do for char in string, and if our char is equal to an opening parenthesis, we will go ahead and increment that score right here. Otherwise, if that character is a closing parenthesis here, we will go ahead and take our score and subtract 1 instead. I think... yeah, it's elif in Python, not else if. Anyway, and if as a result of that our score is less than 0, we need to go ahead and return false here, because we already know that is not a valid sequence of parentheses. Alright, I think we're ready to test this out here. We are going to print... let's go ahead and grab this string right here from the Kata instructions here. We're going to do valid parentheses. We're going to toss that in right here. We're going to run that through the repo here. Python 3 valid parentheses. And it returns true right here. Now, what if we had... this one right here? This would return false. And this one here. Whoops. And that would return false as well. And I think we are ready to punch this into Codewars to see what this looks like. I'm going to run the test. Let's hit attempt. And we are good. Finally, we are going to wrap up this episode with a kata that is near and dear to my heart, and that is rot13. Rot13 is a simple letter substitution cipher that replaces a letter with the letter 13 letters after it in the alphabet. Rot13 is an example of a Caesar cipher. The goal of this kata is to write a function that takes a string and returns the string ciphered with rot13. If there are numbers or special characters included in the string, they should be returned as they are. Only letters from the Latin/English alphabet should be shifted, like in the original rot13 implementation. Let's go ahead and give this one a try here. Let's do def rot13, and we'll have our message here. Now, this kata is going to involve... this kata is going to involve getting the ASCII character code of the letters of our string, and we will need the character codes of the letters A and Z. So what we will go ahead and do, I think we'll do A code, and we'll set that equal to the return of the ORD function. The ORD function will return the ASCII character code or Unicode code point for a single character string. In this case, we want the letter A. Let's go ahead and print that out here. Let's see what that looks like here. Do print rot13. Let's pass in test right here. And let's run that through the repo here. Python 3 rot13. Whoops. And the character code of the letter A is 97. Next, what we'll go ahead and do, I want to see something very quick here. CHR. The CHR function accepts a character code as an argument and returns the character or Unicode string with that corresponding to that code. So A code, let's pass in A code plus 26 here, or rather 25. And I expect a ZZ as the return of that, and we do. And there's just something we want to keep in mind here. I'll do Z code equals A code plus 25 here. Next, one other thing I would like to see. I think Python has a function for translating to lowercase here, right? Yep. And that is going to come in handy here as well. So do message lowercase, and we'll set that equal to message.lower. Now I think we're ready to go through with this. First, we'll go ahead and keep track of a result string here, or result. Set that equal to a blank string here, and then we'll do for char rather in message. And then what we will go ahead and do, want to get to the character code of this character. I want to subtract the A code right here. So what we'll go ahead and do, char code, or rather alphabet code, we'll set that equal to ORD char, and then we'll subtract from that the A code here. And then I think we'll go ahead and print that right here. Me one message lowercase here. Let's see what that looks like. 19, 4, 18, 19. Let's do the first 7 letters of the alphabet. 0, 1, 2, 3, 4, 5, 6. I really want that though. Okay, let's do this. Cipher code. We'll set that equal to alphabet code plus 13. And then we'll go ahead and print the cipher code as well. HIJKLMNOPQRSTUVWXYZ. And the rest of the letters of the English alphabet here. And then what I think we'll do, if cipher code is greater than 25, then we'll do cipher code minus equals 26 then. All right, let's go ahead and we'll do CHR, and we'll pass in the cipher code plus the A code here. And we'll see what that looks like here. B, C, D, E, F, G, H, I, J, K, L, M, N. Yep. I think it is working properly here. Now, what we will go ahead and do is we will go ahead and do cipher letter, and we'll set that equal to char. We'll pass in the cipher code here. And then, doesn't Python have a function called isUpper? Let me just see some here. Let me go into the repo here. Yep. That is gonna help. So what we'll go ahead and do, if right. Okay, I might have to refactor this a little bit here. We actually may need to do a range here. 0 to len message lowercase. And then what we'll do, let's change that to index here. Message lowercase and index. And so if message at index is, or rather, if message at index is equal to message at index dot upper, that's to say if the letter at this current index is an uppercase letter, we will go ahead and do result plus equals message at index. Or rather, cipher letter dot upper. Else, we'll do result plus equals cipher letter. And then finally, we'll go ahead and return the result string here. Run that through the repo here. And get a whole lot of nothing here. What's going on? Do print cipher letter. I am running low on memory here. Let's try that again here. Getting a whole lot of nothing here. What is going on? Alright, let's go ahead and print instead the alphabet code. Now let's go ahead and print the cipher code. Oops. Let's try that here. Because we are forgetting to add back the A code here. Oops. Yep, I think it is working now. Let's bring back that test string right here. GRFG, and that is working properly here. Now, the quick brown fox jumped over the lazy dog. Now, if alphabet code is less than 0 or alphabet code is greater than 25. I think we'll just go ahead and do result plus equals message lowercase index, and then we'll hit continue here. Yep, I think that is working here. Let's grab that string back here. If I'm not mistaken, this very same cipher can be used to bring back the original string. And it does. So I think we are ready to punch this into Codewars to see what this looks like here. And we are good. And that is going to do it for this very special edition of Versus Codewars. I learned a lot today, and I hope you did too. If you like this video or you learned something new, drop a like and subscribe to this channel to see me take on more coding challenges on Codewars. If you think there is anything I can do to improve on my code for the better, feel free to drop a suggestion in the comments section below. Also, if you are a Kata author on Codewars, and you would like to share your authored katas with me in either JavaScript or Python, or maybe another language, feel free to drop links to those katas in the comments section below, and you might see me take on those katas in a future episode of Versus Codewars. I hope you have a wonderful day, and I will see you on the next episode of Versus Codewars.